Okay, ladies and gentlemen, here we go. We're live this fresh Monday morning, August the 27th. It ain't Monday morning. It's a what? It's Monday afternoon, ladies and gentlemen. Monday afternoon. I know. Next week, take Monday and Tuesday off on me. Tell them Palmer said you could. All right. There you go. I got you. All right, ladies and gentlemen, here we go. So, from stage 1, stage 2, stage 3, how are they changing? Huh? 2 blocks. They're going up by 2, right? All right, so if I go stage 1 is 1, stage 2 is 2, stage 3 is 3. So my question is this. Can you see the previous stage? Can you see the previous stage? See the yellow here is the previous stage there. And you're doing what? Adding 1 to what? Ends of it, right? See, this one is 1, 2, 3, 1, 2, 3. They're adding on the ends, right? So my question would be, when I get to it, if I ever get to it, here we go. Ready? How many's in stage 1? Just curious. How many's in stage 2? Stage 3? Good. Now, if I said how many were in stage 4, could you tell me? How many? 9. Okay. So next would be 9, and then we'd go to where? Okay, good. So, here's something. Let's see if you can get this, whippersnappers. What if I said how many were in stage 0? 0? 1? Is it 0 or 1? Huh? Prove it. So, from this number, I would have to go up 2 to get 3, right? So if I do that, that's how many? 1, right? Any questions? Was that hard? Okay, good. Let's fill in the table. How many of y'all were able to do that? Raise your hands. Sweet Jesus. All right. Good job. Yes. No, not yet. We learning. All right. So help me fill in this block. Yeah, come on. Come on. In stage 1, how many blocks do we have? 3. How about stage 2? What about 3? 4? 5? Okay. Now, ladies and gentlemen, what you should see is this. Because, I got an old table here. And tables are only good for 2 things. Eating on them. I'm sorry, I didn't mean to move y'all so the communication would be across 3 or 4 people. That was very rude of me. Wow, let's make it across the whole room next time. AT&T and Verizon and T-Mobile and Sprint and Cellular One, all them people, y'all swap digits, talk to each other at night, not my classroom. Bless you. Unless y'all give them winning lottery tickets, and then you can share them with me. It's the only time. Okay, so part C says show where the rate of change is in your table. Now, were you able to do this? Wake up, Sleeping Beauty. Lord help him. Son, you're going to need more sleep than this to get pretty now. Come on. You do that at night. So, how far is it from 3 to 5? How about here? All of those 2, what are these? All right, so I'm going to teach y'all something. Pay attention. Here you go. Your equation is y equals kx. Now, I'm going to tell you what k is. The k we're going to refer to as the K as this, the constant of proportionality, right? K is the constant of proportionality, or the constant rate of change. Okay, that's the K. Now, these little jokers right here, the Y, the equals, and the X, those all are like a rubber stamp. Y'all know what a rubber stamp? How's a rubber stamp do? Hit the ink, and then hit the what? Paper. So, here you go. Y equals, uh-oh, my bad, sorry. Y equals X, right? That's my rubber stamp. So my question is, guys, what's the K? What's the constant of proportionality? 2 over what? Right, that's 2 over 1, which is nothing more than what? Yes, the change in Y over change in what? X, right? All right, so that I'm going to put 2 right here. Y'all okay with that? That's the equation. How many of y'all, raise your hand. Can I get a raise? Amen, brother. Good. How about anybody else? Anybody get there? Anybody get to there? No. All right, how many of y'all got just Y equals 2X? Can I get it? Can I get you? Anybody get further than Y equals 2X? Okay. I know he's right. What you get? Yeah. Yeah, dude. COP is the same as changing Y over changing X. They're the same thing. It's kind of like a royal blue, navy blue, Carolina blue. They all blues, right? You know what I'm saying? Yeah. So, yeah, they just multiple words that mean the same thing. It's all right. It's there to confuse you. Right? Math is mental abuse to humans. We have to maintain that status. We do not want anybody to go, I love math. Right? That would be so wrong on so many levels. No, I'm just kidding. All right. Yes. We ain't done yet. Give me just a second there, whippersnapper. Give me 1,000 seconds in. Okay, guys. Raise your hand. Demeter. You and Miss Sig Grace. And Mr. Mitchell there. That's not going to be a good situation. Ladies and gentlemen, how many of y'all got Y equals 2X? Raise your hand. All right, good. Raise your hand if you did not get Y equals 2X plus whatever, or Y equals 2X period. All right, let me put it out. Raise your hand if you couldn't get an equation. All right. Okay, so we got to fix some things here, right? First off, Y equals X, that's like a rubber stamp. That's the red, right? The 2 is the COP. Where do we get the COP from? From the table, right? The change in Y over change in what? X. Good. Now, so if I take, listen, if I take this little joker right there, hold up. Got some. If I take this little joker right there, that 1, and plug it in for X, then it says I should get 3 out, right? That's what it says, does it not? Yeah? Okay, good. So, what is 2 times 1? But it says I ought to have 3. I got 2 out, but I need who? So what would I need to do? Add 1. What would you do if I told you, young folks, you have already seen the answer to that? Yeah? What if I told you you'd already got it? Let me show you. This is beautiful. Ready? How many blocks was there in stage 0? Thank you. How many is there in stage 0? 1. How many do we have to add to our Y equals KX? So it's messed up, ain't it? Man. Okay, so let's go to the next one, because I want y'all to see something. So look right here. See, if when I checked my X value, if my X value gave me exactly what I needed in that right side and that output side, then we would say that it's a proportional relationship, right? Now, for it to be not a proportional relationship, we'd have to add something or subtract something after the KX, right? To get it to where we needed to, right? Because it started somewhere other than 0. That's exactly right. That's a guarantee right there. Guaranteed. Y'all know what that is? Huh? All right. Any questions? Y'all good? All right, let's go next. Gotta go answer this next one. Okay. Now, oh my. We gotta graph this thing. And to graph it, we gotta understand some things. What is the label for our x-axis? What did you say the label was for your x-axis? It's the who? It's who? It's the stage, or stages, right? What's your label for the y-axis? Number of who? That's exactly right. Love it. Y'all ready? Right here, 0. So let's do 1, 2, 3, 4, 5, 6, 7. So good with that? And then let's do right here. 1, 3, 5, 7, 9, 11. That looks like a 4, doesn't it? 11, 13, right? Any questions? Okay, here we go. 1, 3, 2, 4, 9, and 5, what? If we were to connect those, what would it form? A straight what? Line. Anytime you have a constant rate of change, if you have a constant of proportionality, it is the same no matter what. It'll always produce a line. Here, I don't care who you are. A line. Now, what we're supposed to do right here with this, these dots, we're supposed to create what? We can do that, but what are these right here? So how am I going up them stairs? 2 and what? 2 and what? 2 and what? 2 and what? Alright, up 2 and over what? 1, right? So if I can go up 2 and over 1, I can go over and down. Guess where I end up at? Well, how about that? Now, any questions? See, we found that that it touches the y-axis at 1, right? Which would give us this equation, y equals 2x plus 1. You okie dokie? Yeah? You okay with that? Now, let's see what else we need. Well, it said write an equation. We're good on the equation, right? Whew. Excuse me. Sorry. The pattern above is a linear pattern. Describe how a linear pattern grows. Describe what the graph of a linear pattern looks like. Well, how does it grow? By a constant what? Constant ratio or constant rate, right? What does the graph of a linear pattern look like? Straight line. Good job. Now, any questions about said problem? Y'all good? Everybody can do it. Everybody can? All right, let's see. Flip page, ladies and gentlemen. Flip page, ladies and gentlemen. Let's see what you can do. Go to the bathroom. I'm going to give you, let's see, anytime. Now, ladies and gentlemen, how many blocks are in stage 1? Oh, my. 1. How many blocks? Well, y'all getting, listen. 1. How many's in stage 2? How about stage 3? How many? How many's in this? Huh? 10. Oh, it didn't do it, did it? There it is. No, don't let him drool all over the desk. Now, how are my stages changing? By how much? By 3. How you know? Do you see the previous box in the shape as it continues on? No, y'all don't. I see it right there. And then I see this one, right? And then I see this one, right? I mean, I like this. It's cool. Y'all see that? That's so cool. It is. Thank you. Appreciate that. Any time of the week, baby. Huh? Broccoli and cheese. Yeah. Mm-hmm. Okay, now I'm just curious about one thing. I want you to tell me how many of them there blocks are in stage 0. How'd you get -2, Leo? Do what now? You got to subtract 3 from 1. Why did he subtract 3 from 1? Go. Huh? It goes up 3 each stage. So if he goes 3 back from 1, he's going to be at where? -2, right? Where might we see that -2 show up again in the equation? What does that tell you about this pattern? Is it proportional or no? It's not proportional. Why is it not proportional? So I'm going to go through the origin because where's it starting at, ladies and gentlemen? -2. How do we know we're starting at -2, guys? Stage 0 is at -2, right? All right, so here. I should have wrote that down, shouldn't I? 4, 7, 10, right? No, wait. 1, 4. 1, 4, 7, 10. All right, all of these babies are going up by how much? And then these are going up by how much? Now, how do I know they're going up? How do I know it's a +3? Yeah, because I'll have a negative sign. Yeah, but why? How am I going to know? The number of blocks are growing, right? So it's increasing, right? Okay, so that's why it's a positive. My K is changing Y over changing what? X, right? That's the constant of proportionality, right? Which is 3/1. You okay? All right, now, what's my rubber stamp? What is my rubber stamp? Y equals really the KX, right? Let's just go ahead and call it like it is. Now, guys, what's the K? Now, let's check it against my table. Let's do this. When my table has an input of 1, how many boxes at stage 1, how many boxes should I get out? Oh, you're right. Apologize there. I jumped the gun. At stage 1, excuse me, I should get 1 box out. So let's do it. 3 times 1 is how many? I'm at 3 boxes, but I only need how many? So what I got to do that 3? -2, baby. How many blocks did we have at stage 0? Quinkydink? No, I don't think so. Those two numbers are the same. They're the same, ladies and gentlemen. What do you think? How many of y'all like? Holla, got this. There you go. Now we're chilling. Good. Okay. All right. Here we go. So we got to, let's graph this joker. When we graph it, look at my graph. I got the dots on there. I didn't label my axes, did I? And then number of blocks, right? So when you do that, you can see that my change is up by 3 and over how many? 1. See, you're going to be given graphs, and you're going to have to determine what is the constant of proportionality, what is the K. And ladies and gentlemen, you have to draw a staircase. And that's how you're going to figure it out. Questions? Y'all good? Sweet. Y'all said the equation. What was the equation? Uh-huh. I love it. Y'all getting this together. Hey, here's, if this pattern is a linear pattern, you support an evidence from each of your representations to justify your answer. So if this is linear, how are we going to know it's linear? First off, let's go back right here. If this is linear, how should we know that the stages are changing? Huh? You got to tell me something a little bit more than that. Come on. How do I know it's linear? Go. It's going at a constant rate of what? Change. Constant of proportionality, right? Change and constant proportionality, they're the same. So they're all changing by the same amount, right? Each time you go up to the next, it'll change, same amount. Then the next step, it'll change. What about this right here table? How can I see if it's linear? What do I need to do? What did we do? We looked at its what? We need to pray. Come on, folks, wake up. You wouldn't do enough snoring, don't worry about it. How am I going to be able to tell in a table if it's linear? Go. No. Table. This table, go. It has a constant rate of what? That's right. See, I look at my x's, then I look at my what? That's it. That's all I got to do, right? Yeah, if it's going up the same, then it's constant, guys. And if it's constant, then it will produce a straight line. Good. What about right here? Here. Look right here. What about that graph? How am I going to be able to tell? Here. Right here. How am I going to change? How am I going to be able to tell whether that is a linear relationship or not? How am I going to know that that's linear? Right here, this graph. I mean, walks like a duck, quacks like a duck. I'll call it a duck, but let's look at the graph. Go. But how do you know it's a straight line? No. Just take go through the origin. I ain't going to go through the origin. Yeah, go. There's a constant rate of what? Did y'all hear that answer 3 times? Yeah. So how do you tell if you got a linear relationship? It has a constant rate of what? That's exactly. See, I can do the staircase here, right? I can say, ooh, up 3 over 1, up 3 over what? Up 3 over 1. See how that's constant? Do y'all see that? It's a wonderful thing, right? Okay. Any questions? Anybody? Anybody? Everybody's good on this? Well, sweet Jesus, let's give you a sheet to see what you can do. We about to give you homework, folks.